In this video, I'm going to solve the second example of integration by parts, which is this super nice technique. I'm going to start by picking up, we have this here, the formula. I'm going to pick a u and I'm going to pick a v prime. Again, I'm going to pick to be u this x. So I'm going to write it here, it would be u, it's equal to x, and I'm going to pick to be v prime, the cosine of x. So I'm going to write here, the v prime would be equal to cosine of x. There it is. Now I'm going to, in order to fill in the whole formula here on the right side, we need to find v and v, use it in these two places, and we need to use to find u prime. So I'm going to start getting u prime, which is pretty simple. The derivative of u, in this case, if u is equal to x, its derivative will be equal to 1. And now we have to, in order, if we start from v prime, in order to find v, we need to integrate the cosine of x. So the integral of cosine of x would be equal to sine of x, and with that we got everything we need to fill in the blanks with the formula. So let's see, it will be equal to x, this u. Now v, which is would be sine of x, I'm going to place it in here, would be x times sine of x, then would be minus the integral of v, which is going to be sine of x, and then times u prime, which we found it to be this one. I'm going to write it completely. There it is. So from here, well, I'm actually going to write it in a nicer way. It would be x times sine of x. It would be minus the integral of sine of x dx. And well, actually, this integral of sine of x dx, we know what's its solution. So let's get it here. It would be x sine of x would be minus the solution for this sine effect, which is actually, I'm going to write it this way. It's minus, I'm actually going to take away the point, would be minus cosine of x would be plus c. I write here this with a parenthesis because we have this negative sign outside, so I'm going to simplify it in the next step. I know it's I'm using a lot of steps, I'm just trying to make it as clear as possible. So it would be here plus cosine of x plus c. And there it is. Actually, this is the solution for this integral that we started with. Now I'm going to prove it using the fundamental, this idea of the fundamental calculus theorem. That is to say, I'm going to take the derivative out of it. So I'm going to take the derivative here on the right side. So if I take the derivative of x times sine of x plus cosine of x plus c, there it is. If I take this derivative, I should get back to x times cosine of x, which is where we started. So here, this x times sine of x is a product, so it's going to be its derivative sine of x times 1 would be plus x times derivative of sine would be cosine of x, then would be here derivative of cosine would be minus sine of x, and derivative of c would be 0. So let's simplify this out. This part would be equal to sine of x be plus x times cosine of x minus sine of x, and I'm pretty sure you can notice that these two guys will cancel out, and at the end we'll have this equal to x times cosine of x, cosine of x, and that is where we started, so it means we are right.